Okay, so universe, right? Big place. Turns out you start talking about it and, well, you bump into some pretty big philosophical questions along the way.
Yeah, it's kind of unavoidable, isn't it?
Totally. And lucky for you, that's exactly what we're diving into today.
I am so ready.
We've got excerpts from a paper, Does the Universe Need God? By Sean Carroll.
Oh, I like where we're going with this.
Right. Now, Sean Carroll, he's a theoretical physicist, cosmologist, and really doesn't shy away from those big questions.
She really doesn't.
And in this paper, he dives right into a classic that the universe need, you know, a little something extra to get started.
A creator.
The age-old question.
Exactly. And we're going to unpack Carroll's exploration, looking at the Big Bang. Does it point to a universe that needs a divine architect, or is there another way to look at it? Right, because I think it's important to emphasize right from the start, we're approaching this from a purely scientific perspective. We're looking at what cosmology, as we understand it today, tells us, not about proving or disproving anyone's faith.
Exactly. Think of it more like adding another layer to how you view the cosmos.
I like that, adding another layer.
And speaking of the cosmos, let's talk about the Big Bang.
Yeah.
First things first, this wasn't just some random explosion in space, right?
Oh, not even close. The Big Bang model, incredibly solid. I mean, we are talking mountains of evidence backing it up.
Mountains of evidence. Okay, so what kind of evidence are we talking about here? Like, paint me a picture. What are we looking at?
Well, for starters, we see the universe expanding. Galaxies. They're not just hanging out, they are moving away from each other.
Right, right.
And here's the kicker. The farther away a galaxy is from us, the faster it's moving away.
It's like the universe is constantly like inflating like a balloon or something.
That is a really good way to visualize it. Yeah, that expansion. That was Hubble's claim to fame. And it points to everything being much closer together in the past. Then there's this faint afterglow. We see it everywhere we look in space. It's called the cosmic microwave background radiation.
Right, like an echo of the Big Bang.
Exactly, an echo. And get this, the properties of that radiation. A perfect match for what we'd expect if the universe was once unbelievably hot, unbelievably dense, just like the Big Bang Theory predicts.
Okay, so we've got an expanding universe, we've got this faint afterglow. I mean, it's sounding like the evidence for the Big Bang is pretty solid, but what about the very beginning? That moment of singularity, like, what happened then?
Ah, see, that's where things get really interesting and tricky.
Right.
The singularity, it's like this point of infinite density. All our current laws of physics, they break down.
Yeah, just go, nope.
Basically, our best understanding of gravity, general relativity, can't handle those extreme conditions.
So are we saying that was the actual literal beginning, or is that just our current understanding hitting a wall?
It's a question that keeps cosmologists up at night. Carroll actually talks about two main branches of thought. He calls them beginning cosmologies and eternal cosmologies.
Okay, beginning and eternal. I am intrigued. Let's start with beginning cosmologies. What's going on there?
So these theories, they propose that the Big Bang itself was, get this, a quantum event.
A quantum event. Okay, hold on. You're going to have to break that down for those of us who might not have a PhD in theoretical physics.
Fair enough. So imagine things at the absolute smallest level. Smaller than an atom.
Okay.
Way smaller. Down there, things are fuzzy. The universe is ruled by quantum mechanics, where instead of certainty, you have probabilities.
Right.
These beginning cosmologies, they suggest that the Big Bang itself, it might have followed those quantum rules.
So not your average Tuesday then.
Not quite. One example of this is something called the Hartle-Hawking no-boundary proposal.
Okay, now we're just showing off with the names.
It gets complicated. But the basic idea is that they're trying to describe the universe emerging from this state where time, as we understand it, didn't exist yet.
So the Big Bang as the moment time itself flickers on.
Exactly. And what's important about these beginning cosmologies is that they don't need a creator to make sense. They work within the framework of physics, even if those laws might have been different in those earliest moments.
Okay, so we've got the universe potentially popping into existence from a quantum
Yeah.
something. What about those eternal cosmologies? How do they compare?
All right. Well,
Okay, so we've got universes potentially popping up from quantum foam, existing eternally, maybe even doing a cosmic dance of expansion and contraction. It's a lot to wrap your head around.
it really is. And that actually leads us nicely to the other branch of thought, those eternal cosmologies. These models, they propose that the Big Bang wasn't the beginning of everything, just a phase in a universe that's infinitely old.
So no singularity, no need to figure out what came before. What are we talking about here? like a cosmic boomerang eternally flying through space.
That's one way to think about it. One possibility is a bouncing universe. Imagine a previous universe collapsing in on itself, a big crunch, which then provides the energy for our Big Bang.
Okay.
Then there's the idea of a cyclic universe, with endless cycles of expansion and contraction, big bangs, followed by big crunches, over and over again. We
Wow.
even have the concept of baby universes budding off from a parent universe, each with its own Big Bang.
Baby universe. Okay, now that's just showing off cosmos. But are these ideas really taken seriously, or are we in the realm of science fiction now?
Oh, they're definitely areas of active research, and while they might sound out there, they're all rooted in attempts to create a complete and consistent picture of the universe.
I do love how even when we're talking about the universe's origins, we're still looking for that elegant solution. But whether it's a beginning or an eternal cycle, it seems like we've got a handle on how the universe could exist without a creator. But what about the whole idea of fine-tuning? It's like looking at a perfectly baked cake and saying, wow, the ingredients just happen to arrange themselves in this exact way purely by chance.
It's a very compelling argument. The universe's laws, the constants that govern everything, they seem almost tailor-made for life to exist. Even tiny changes to these values could have resulted in a universe where stars couldn't form or atoms wouldn't hold together.
Yeah, it's not just about the universe existing. It's about it being able to support life as we know it. Like, what if gravity was a tad stronger? We wouldn't be having this conversation.
Precisely. And one of the most mind-boggling examples of this fine-tuning is something called vacuum energy, what we often refer to as dark energy.
Okay, dark energy, the mysterious force pushing the universe apart. Remind me again why this points to fine-tuning.
Well, we can measure dark energy today, and it's incredibly small, but not zero. The problem is when we try to calculate what this value should be using our best theories, specifically quantum field theory, we get an answer that's wildly different.
Wildly different. Like, how different are we talking here?
Imagine trying to balance a pencil on its tip on a planet a trillion times smaller than an atom.
Okay, you officially lost me in the analogy.
But that's the level of precision we're talking about. It's off by at least 120 orders of magnitude.
Okay, I think I get the point.
Yeah.
So, what are the explanations for this, besides, a cosmic creator making some adjustments?
Well, one possibility is that our understanding of life is just way too limited. We tend to think life requires conditions very similar to our own, but what if life is far more resilient and adaptable than we can imagine?
So maybe those parameters aren't so fine-tuned after all. Life
Ah.
finds a way, right?
Exactly. Another possibility is we just got lucky. There's only one universe, and by some cosmic coin flip, the parameters happen to land in the sweet spot for us. But then there's another, even more mind-bending possibility, the multiverse.
Ah, yes, the multiverse. Back to those infinite cosmic bubbles, each with their own set of laws and constants.
Exactly. And this is where the anthropic principle comes in. It's the idea that if there are countless universes with varying parameters, it's not surprising that we find ourselves in one that supports life. Because if it didn't, we wouldn't be here to observe it.
Okay, I see where you're going with this. But that always feels a bit like circular reasoning, like we're here because we can be. It doesn't feel like an explanation, more like a shrug of the shoulders.
I get it, it can feel that way. But think of it like this. Imagine a radio tuned to a specific frequency. We only hear that station because that's where its signal exists, not because it's the only station out there. Our existence as observers biases us towards universes where observers like us are possible. It's not about saying this universe is special. It's about acknowledging that we're looking at it through a very specific lens.
Okay, that's a helpful way to think about it. But how does the multiverse stack up against the idea of a divine fine-tuner?
That's what we're going to unpack right after this.
Okay, so the multiverse could potentially explain away the need for a cosmic fine-tuner. But let's be real, aren't we just throwing a bunch of hypothetical universes at the problem? It's not like we can hop in a spaceship and go check out what's happening in another dimension, right?
You're not wrong. The multiverse is, as of now, beyond our ability to directly observe. But it's important to remember that this isn't just some random idea physicists pulled out of a hat. The multiverse emerges naturally when you start combining well-established theories, things like inflationary cosmology and string theory.
Okay, so walk me through this. How do we go from those theories to multiple universes?
So remember how we talked about inflation, that period of insanely fast expansion in the early universe?
Right.
Well, inflation naturally leads to the possibility of regions outside our observable universe. Places that might have inflated differently ended up with different properties. And that's where string theory comes in.
String theory, the one that says everything is made of tiny, vibrating strings.
Hmm.
How does that fit into this cosmic puzzle?
Okay, so string theory, it proposes that there aren't just the four dimensions we experience, up, down, left, right, and time, but potentially many more hidden dimensions, curled up, too small for us to see.
Right.
And these extra dimensions allow for something called a landscape, a vast number of possible configurations for the fabric of reality. Each configuration could potentially give rise to a universe with its own unique set of laws and constants.
So it's like this mind-blowingly complex cosmic recipe book, with each universe being a different page. Some with gravity turned up to 11, others where time flows backward.
Exactly. And what's fascinating is that the multiverse isn't about adding unnecessary complexity. It's about the elegance of fundamental physics giving rise to incredible diversity.
So we've got these infinite potential universes, each a cosmic experiment with its own unique set of rules. But let's be honest, doesn't that kind of make our existence feel a little less special? I mean, if there are infinite regions of us out there, what's the point of it all?
It's a question that definitely comes up a lot, but I think it's less about diminishing our significance and more about shifting our perspective. We're used to thinking of ourselves as the center of the story, but what if the story is so much grander than we ever imagined?
Okay, I see what you're saying. It's like looking up at the night sky and realizing that we're just one tiny planet orbiting one star in a galaxy full of stars, which itself is just one of billions of galaxies, and now potentially one of countless universes. It puts things in perspective, doesn't it? But after this deep dive into the cosmos, where does that leave us with the question of a creator? If cosmology provides ways for the universe to exist without divine intervention, do we still need the idea of a god to fill in the gaps?
That's the crux of Carroll's argument, isn't it? He's not saying we can definitively prove or disprove God's existence through cosmology, but as we continue to uncover these naturalistic explanations, the need for a divine creator to explain the universe's existence, or even its fine-tuning, becomes less compelling.
Right? It's like that classic God of the gaps argument. But what I find really intriguing is something you mentioned earlier, the incredibly low entropy of the early universe. It's like the universe started in a state of extraordinary order, even more so than we'd expect if it was simply fine-tuned for life.
It's a huge mystery, and honestly, one that the multiverse doesn't fully solve. Because you're right, if the universe was somehow designed with life in mind, why go through all the trouble of setting up such an incredibly specific initial state? It's like the universe is going above and beyond, putting
Yeah.
on this cosmic magic show where the setup is just as impressive, if not more so, than the final act.
So what does this all mean? What are we supposed to make of a universe that seems both strangely inevitable and unnecessarily spectacular?
That's the beauty of it all, isn't it? There's still so much we don't know. And that's okay. Exploring these big questions, pondering the possibilities, that's what makes cosmology so captivating.
It certainly keeps us on our toes. So to our listeners, after this deep dive, what do you think? Are we part of a grand design? A cosmic accident? Or is the answer somewhere in between, in the realm of possibilities we haven't even begun to imagine? Until next time, keep looking up and keep asking those big questions.